The core paradox, expanding into nothing. Right now, the universe is expanding at an incredible rate. Every second, the space between distant galaxies stretches by thousands of miles. But here is the concept that breaks our intuition. It is not expanding into anything. There is no giant cosmic warehouse, no outer boundary, no bigger container waiting to be filled. We are about to explore the most mind-bending concept in science, how space creates itself from nothing. Asking what is the universe expanding into is like asking what is north of the North Pole. It's a question that seems logical but is based on a flawed assumption. Why our intuition is wrong. We naturally picture expansion like a balloon inflating in a room. The balloon grows because there is space around it to grow into. This is how everything in our daily experience works. Plants grow into air, cities expand into the countryside. But the universe does not follow this logic. The universe is space itself. When we say it's expanding, we don't mean it's stretching into a pre-existing void. We mean that the very fabric of space is stretching, creating more of itself as it grows. The balloon analogy, corrected. Imagine the surface of a balloon with dots on it. As you inflate it, every dot moves away from every other dot. No dot is the center. The surface itself is expanding. Now imagine this in 3 dimensions. The galaxies are like the dots, and space is the stretching surface. It's not expanding into anything. The surface is all there is. How we know this is real? The stretching of light, scientists discovered this by observing light from distant galaxies. Edwin Hubble noticed that farther galaxies are moving away from us faster than nearby ones. This isn't because we're at the center of an explosion, but because space itself is stretching. This stretching affects light itself in a process called cosmological redshift. As light travels through expanding space, its wavelength gets stretched. Analogy: imagine walking on a moving walkway that is itself stretching. Your steps are the same, but the ground lengthens beneath you. For light, a beam of blue light from a distant galaxy can be stretched into red light by the time it reaches us. The light isn't changing color because the galaxy is moving away quickly. It's because the space it traveled through expanded. The light from the most distant galaxies has been stretched to nearly 40 times its original wavelength. This means the universe was 40 times smaller when that light began its journey. The expansion is everywhere, but you can't feel it. This expansion is happening everywhere, including in the space between your eyes and this screen. The reason you don't notice it is that the forces holding atoms together, electromagnetic forces, are vastly stronger than the force of expansion. Only across the vast empty distances between galaxies, where no forces oppose it, does the expansion become dominant and measurable. The limits of what we can see, the cosmic horizon. When you look at the night sky, you are not seeing the entire universe. You are trapped inside an observable bubble with a radius of about 46 billion light years. This limit exists because the universe is 13.8 billion years old. Light travels at a finite speed. The oldest light that could possibly have reached us has been traveling for 13.8 billion years. However, because space has been expanding all that time, the galaxy that emitted that ancient light is now actually 46 billion light years away. Everything beyond this 46 billion light year horizon is the unobservable universe. We can never see it, no matter how powerful our telescopes, because its light hasn't had enough time to reach us. If the universe is infinite, the part we can see is effectively 0% of what exists. The edge of observation, the cosmic microwave background. The oldest light we can see is the cosmic microwave background, CMB. It's the afterglow of the Big Bang, released when the universe was only 380,000 years old. Before this, the universe was a hot, opaque plasma. Light couldn't travel freely. When the universe cooled enough to form the first atoms, it became transparent, and that first light burst free. This radiation now fills every cubic inch of space, cooled by expansion to just a few degrees above absolute zero. It is the ultimate observational horizon. We cannot see any events before this moment. What lies beyond our sight? The universe appears to be homogeneous, roughly the same in all directions on a large scale. This suggests that if you could teleport beyond our observable horizon, you'd likely find more of the same, more galaxies, more stars, and possibly more planets. This leads to a staggering implication. If the universe is infinite, then every possible arrangement of matter must repeat. There are other versions of you reading this sentence in distant, unobservable regions of space. There are versions where you made different choices and versions where Earth never formed. This is not mysticism, but a mathematical probability in an infinite space, the engine of expansion, dark energy and inflation. So what is driving this expansion? The answer appears to be dark energy, a mysterious force that makes up about 68% of the universe. What's weird about it? Normal matter and energy become less dense as space expands. Dark energy, however, maintains a constant density. As the universe grows, more dark energy appears to fill the new space. The effect? This creates repulsive gravity, pushing space apart and causing the expansion to accelerate. About 5 billion years ago, dark energy became the dominant force, and we now live in the age of acceleration. This process echoes an even more dramatic growth spurt in the universe's first moments, cosmic inflation. In a fraction of a second, the universe expanded exponentially, from smaller than a proton to roughly the size of a basketball. This rapid inflation solved several cosmic mysteries and set the stage for the universe we see today. The ultimate fate. Dark energy's acceleration points to a cold, empty future known as heat death. Over trillions of years, stars will burn out, galaxies will drift apart, and matter itself may decay, leaving a universe that is a uniform, lifeless void at near absolute zero. A more violent end, the Big Rip, is possible if dark energy strengthens. In this scenario, expansion would eventually overcome all forces. First gravity, then molecular bonds, and finally atomic nuclei, tearing all matter apart. Conclusion: the question itself is flawed. The journey to answer, what does the universe expand into, leads us through incredible concepts. But the deepest answer is that the question itself is based on a mistake. The universe is not expanding into anything because it is space. It creates the very concept of into and outside as it grows. Expansion isn't the universe filling a container, it is the container itself getting larger. We are not just observers of this expansion, we are part of it. Our consciousness, our questions, are the universe awakening to understand itself. The universe expands into its own potential, into mystery and wonder, and we are a magnificent, conscious part of that endless process. The multiverse and higher dimensions. The concept of inflation doesn't just explain our universe, it suggests the existence of a multiverse. If inflation happened once, quantum physics implies it could happen endlessly, creating countless bubble universes within a vast, ever-expanding cosmic foam. Different realities. Each of these bubbles could have different fundamental laws of physics. Some might have stronger gravity, rendering stars impossible. Others might lack the electromagnetic force, making chemistry non-existent. Our universe is just one bubble where the laws accidentally allowed for galaxies, planets, and life. The anthropic principle. This is why our universe seems fine-tuned for life. We don't live in a special universe, we live in one of the rare habitable bubbles where the conditions allow us to exist and ask these questions. But what if the answer to what does it expand into is even more literal? String theory proposes that our universe has more than the 3 spatial dimensions we experience. 6 or 7 additional dimensions could be curled up at a microscopic scale. The brain model. In this view, our entire 3D universe could be a membrane, or a brain, floating in a higher dimensional hyperspace. In this scenario, our universe could be expanding into these higher dimensions, like a balloon's surface expanding into our familiar 3D room. Other brains with their own universes could be floating just a millimeter away, in a direction we cannot point to or perceive. The nature of nothing, the quantum foam. We think of empty space as a true void, but it is not. At the tiniest scales, at the level of the Planck length, space itself is a seething, turbulent quantum foam. Virtual particles. According to quantum mechanics, pairs of virtual particles and antiparticles constantly pop into existence from nothing, borrowing energy from the vacuum and annihilating each other almost instantly. This is not a theoretical curiosity. It creates measurable effects, like the Casimir force, which pulls 2 metal plates together in a vacuum, the vacuum catastrophe. This quantum activity should give empty space an enormous amount of energy. When physicists calculate this energy, the result is 10 while 120 times, that's a 1 followed by 120 zeros, larger than the energy we observe driving cosmic expansion. This is the biggest discrepancy between theory and observation in all of science. Either our understanding of quantum mechanics is fundamentally wrong, or some unknown mechanism cancels out almost all of this vacuum energy, leaving behind the tiny fraction we call dark energy. The illusion of now and the stretching of time. Einstein taught us that space and time are woven together into a single fabric, space-time. You cannot stretch one without affecting the other. Cosmic expansion stretches time itself. Time dilation. When we look at a distant, rapidly receding galaxy, we see its events unfolding in slow motion. A supernova that takes weeks to unfold in a nearby galaxy would appear to take much longer in a faraway one. This is because the expansion of space stretches the time between the light pulses reaching us. No universal now. The concept of what is the universe doing right now is meaningless on a cosmic scale. Events that are simultaneous for you are happening at different times for an observer in a distant galaxy. The present moment is local, not universal. The far future, a universe of isolation and ignorance. As dark energy accelerates expansion, the cosmic future becomes one of increasing isolation. The disappearing universe. In about 150 billion years, all galaxies outside our local group will have been carried beyond the cosmic horizon by expansion. Their light will never reach us again. The night sky for future astronomers will be almost empty. The end of cosmology. These future scientists will see only a single giant galaxy, the merger of the Milky Way and Andromeda, in an eternal static blackness. The cosmic microwave background will be redshifted into undetectability. They will have no evidence of the Big Bang, an expanding universe, or other galaxies. They will conclude incorrectly that their lonely galaxy is the entire unchanging cosmos. We are living in a uniquely privileged cosmic era, able to see the evidence of our own origins before it vanishes forever. The final answer. A celebration of the mystery. So what is the universe expanding into? The ultimate answer is that the question is a category error. The universe isn't expanding into a pre-existing space because the universe is all the space there is. It creates the very concept of where as it grows. Asking what it expands into is like a character in a novel asking what page the book is printed on. The character exists within the story. The page is the medium of a reality outside their own. The universe expands by becoming more itself. It is a self-creating, self-sustaining process. We are not just passengers on this journey. We are the universe itself, a part of space, time, and matter that has become complex enough to feel awe, to ask questions, and to marvel at its own existence. The question transforms from a scientific puzzle into a philosophical celebration. The universe expands into potential, into complexity, into mystery, and into the breathtaking improbability that a part of it can look back and wonder. We are the universe awakening, and in that realization, the search for an answer becomes its own beautiful, profound destination. The universe as a computational process. What if expansion isn't a physical motion but a computational process? Some theoretical physicists and philosophers propose that the universe might be fundamentally informational. In this view, space isn't a thing that stretches, but a relational network being continuously calculated. The universe as a simulation of itself. This isn't about a literal simulation run by aliens, but about the nature of reality itself. The laws of physics could be the algorithm. The expansion of the universe, then, would be the execution of this code, with new bits of space-time being computed into existence every moment. The void it expands into is not a spatial void, but a potential state, like the blank memory in a computer waiting to be allocated. The question, what does it expand into, becomes what hardware is running the code, a question that may have no meaning within the simulation itself. The end of physics and the landscape of possibility. Our current understanding is based on the assumption that the laws of physics are fixed and universal. But what if they aren't? The landscape of string theory. String theory suggests a vast landscape of possible universes, each with different physical constants and laws. Our universe is just one point in this landscape. In this context, expansion could be a process that actively changes the local laws of physics. The early universe, in its highly compressed state, might have operated under completely different rules. As it expanded and cooled, it crystallized into the physics we know today. Perhaps expansion is the universe exploring its own potential states, and we are just along for the ride in a stable, habitable pocket. Consciousness as a cosmological force. This is the most radical frontier. We assume consciousness is a passive byproduct of a physical brain, but what if the relationship is deeper? The participatory anthropic principle. Proposed by physicist John Archibald Wheeler, this idea suggests that observers, us, are necessary to bring the universe into being. It's not that the universe was fine-tuned for life, but that life, through the act of observation, fine-tunes the universe. In this mind-bending view, the universe only becomes concrete and definite when observed. The expansion and the entire cosmic history we've deduced is a retroactive construction. The Big Bang didn't happen until the first conscious entity looked back and saw its evidence. We are not just the universe understanding itself. We are the universe birthing itself through observation. The ultimate fate beyond heat. Death, even the bleak heat death, a state of maximum entropy, might not be the end. Poincaré, recurrence and quantum resurrection. On a timescale so vast it defies any metaphor, like 10 to 10 to 10 b other 56 years, quantum fluctuations could, by pure chance, cause a spontaneous decrease in entropy. Given infinite time, even the most improbable events must occur. A new Big Bang could randomly erupt from the quantum foam of the dead universe. This suggests a cyclic cosmos, not in a regular rhythm, but in sporadic universe-spanning resurrections. the universe as a quantum error. Another possibility is that our universe itself is a rare, stable fluctuation in an eternal, higher dimensional quantum vacuum. Its birth, expansion, and eventual death are just a single, long-lived blip in an otherwise featureless meta-reality. Its expansion is simply the unfolding of this single, cosmic-scale quantum event. Synthesis, the unanswerable question as the answer. After this journey from the firmly established to the wildly speculative, we return to the original question, now transformed. The question, what is the universe expanding into, is not a question that can be answered from within the universe. It is a meta question. Any answer we can conceive of, a higher dimension, the multiverse, nothing, a quantum state, is necessarily framed by the concepts of space, time, and causality that the universe itself provides. The true function of the question is not to be answered, but to act as a gateway. It is the ultimate koan, a riddle designed to shatter our conventional thinking and force us to confront the limits of our models and our minds. The universe is not in a container, it is containment. It is not in time, it is time. We are not looking at it from the outside. We are a temporary pattern within it, a knot of space-time that has become complex enough to feel awe and wonder at the infinite, self-generating process that it is a part of. The universe expands into a question. It expands into a mystery that generates more beauty, more complexity, and more wonder with each passing moment. And we, in our fleeting, conscious form, are that mystery becoming aware of itself. The journey to understand the expansion is the universe's way of creating meaning within itself. The search is the destination. The question is the answer.